Matt, you're absolutely ready to go. Good to go. Over to you.
Okay, thank you very much. All right. Hey, everybody. I'm going to get straight into it, and there'll be some time for questions at the end. I'm very much looking forward to that. Let's not waste any more time. In we go. So today, I'd like to talk to you about designing interfaces like you're seeing now. Everything in this video is controlled by gesture. It's controlled by moving your hands around in the air. And we're at a point now where technology can detect your hands and your body and your motions, and it can respond in a way that's quite natural and instinctive. So these are what we call gestural interfaces. They're controlled by the hands. They're also spatial, which means they exist in 3 dimensions in the world around you. So we're at a point where this technology will allow us to design interfaces that can escape the confines of the screen if we want. They can be all around you, even on your body. And, you know, I'm an interaction designer. I find that quite exciting because in a lot of ways it's tearing up the rule book on what we know about UX design and interaction design today. So we've got this opportunity to define this kind of whole new world of interactions that extend beyond the screen. Now, I said that gesture can be natural and instinctive to use, and that's because we all know how to use our bodies. You know, we wave at people we know, we point at things that interest us. You don't need to think about using your hands per se. They're the controllers you already know how to use. You can do amazing things with. So gestural interfaces for me are, you know, this is likely to become another modality alongside touch and alongside voice and things like that, that we as designers are going to have to be working with. So I don't believe that these kind of interfaces are going to replace what we do on screens, more that you'll be seeing them alongside. You're going to see more variety, more flexibility in the years to come on the way you can interact with digital content. You may have VR headsets, AR glasses, you may have voice, you may have touchless displays even. So the way you would interact will depend on the device you're using and on the scenario, which is all to say that designing for screens, I think, will not be enough in the years to come. But maybe we can give you an introduction today and do something about that. So why listen to me when I'm making claims like that? Well, in short, I've been doing design for a while. I've been in it about 20 years. I've spent the last 3 focused completely on spatial and gestural interfaces, Ultraleap, and I'll be showing you a bit more about that in a minute. My background's in product and industrial design. I started out as a Lego designer going way back, and plenty of interesting stories about that too, but that's not the focus of today's talk. And I've moved gradually over the last 20 years from doing physical products to digital. So the focus today for me, in all my last few jobs, is emerging forms of interaction design. It's VR and gesture. So today I work at a company called Ultraleap, where I'm the design director. I lead up a team of interaction designers and user researchers. And we're working with hand tracking and haptics technologies. So that's what Ultraleap does. It creates this tech. Ultraleap's the creator of the Leap Motion camera, which some of you might be familiar with already. Now, the hand tracking essentially can track your hands in 3D space. And with another device, a haptics device, which I'll show you a little bit later, we can also deliver haptic sensations to the hands and to the fingers as you gesture in the air. So this technology that we make can get embedded into a whole range of devices, from VR headsets like you're seeing in this picture, to touch screens and even things like cars. And in every case, it can translate gestures from your hands into inputs for the interface. So the result then are digital devices that know what your hands are doing. They know the shape they're making, the position in 3D space, the speed and the direction of movement. So when you're doing these natural things like waving and swiping and pointing, your devices can understand that. So then the interesting question becomes, well, if you work as a UX person, you know, what can I do with this stuff? So to start out, if you work in VR or AR, you're probably used to controllers, VR headsets usually come with these plastic controllers you hold in your hands with lots of buttons on them. And you can do a lot with them, but for new or infrequent users, and that's still usually most people in VR, it can be a little bit of a barrier. There's a bit of a learning curve there. If we use hand tracking, we have the option to not always be using the controllers. We can take away a bit of the awkwardness of the first use. Anyone who's used VR knows once you've got the headset on, you're often fumbling around for the controllers or trying to remember what some of the buttons do. So if applications are well designed, it's possible to be getting people in having fun or getting work done more quickly than before. Now, the other thing that VR with hands is really good for is enabling people to better train for real world scenarios. So at Ultralit, we've got a lot of customers who work in virtual reality training. It's something we're seeing sort of a growing demand for in the last few years. And we're seeing it used for all sorts of scenarios, from helping airline cabin crews train, like in this example here from Lufthansa, to people like hotel staff, or even really specialist jobs like surgeons or fighter pilots. And in most cases, it's a kind of practical consideration. It's cheaper and it's more convenient to do some stuff virtually than it might be to set up some of these scenarios in real life. You know, it's easier than getting a passenger jet for the day or setting up a fake surgery or whatever. The other advantage is that because you're using your hands now, you can practice these procedures in a manner that's a bit more natural and a bit closer to the real thing. Now, that same hand tracking technology can be used to make entirely new types of interfaces as well. So here's my colleague using a touchscreen that we've turned into a touchless device. She's controlling it from a distance with gesture. You should be able to make out her hand controlling that cursor that tracks around the screen. So what's going on now is, because we can recognize your hands in 3D space, effectively the volume of air in front of the screen, the gap between your user here and your screen, is now part of the interface. Wherever your hands move in that 3D volume, we're seeing it and we're translating it to something on that screen. So that starts with controlling a cursor, but then we can also do more with it. So now, because we know where you're pointing, rollover states become possible on a touchscreen. The UI can come to life as you navigate around. And then, because you're not just using a simple pointer, you've got a whole hand, you can do more complex stuff, like you can grab 3D objects like the trainer on that screen and pick them up and turn them over to inspect them. So even with a touchscreen, I think this can enrich these experiences. It adds this layer of responsiveness that wasn't there before. I'm going to wager that pretty much everyone on this call works with designing interfaces for screens. I mean, maybe some of you have done some spatial stuff before. I'd be really interested to hear. But most people here will be very experienced in designing for screen interfaces. You know, we work with this quite mature ecosystem. We know the components, we know the touchscreen gestures. There are good standards for usability and accessibility, especially if we do stuff in web. The trick with the spatial and gestural interface stuff is that it's still starting out. It's not had the time and attention from designers and developers that will get it to the same level of maturity. And that's really what my job and my team's job is. So we're conducting interaction research to try and help write the rule book for this stuff. Our goal ultimately is to deliver a toolkit of design guidelines and an SDK that will make it easy for everyone on this call to kind of build their own interfaces to best practice. It's a big project. There's a lot to do. We've been at this years and there's still plenty more to do. But we do know some of the components and the gestures and the principles already. And over about the next 20 minutes, I'd like to give you a bit of a crash course in some of the key principles and some of the most important gestures and components we found. So we'll start simple, and that's, how do I select stuff with gesture? How do I push a button effectively? So on screen here, I've got a couple of examples. On the right is an example in virtual reality, and on the left is an example of a touchless display. So in VR on the right, we've got a virtual hand there. So that's our real hand is moving in front of the headset, and the Ultralit technology is tracking it and overlaying a virtual hand. So You see the hand in VR just like you would in real life. We reach out to push that button and you can see it change color. You can probably see it depress a bit. So it reacts as you would expect a button to in real life. So that's pretty straightforward for us. That it's, you know, as intuitive as it could be. It's a little different on the touchless display on the left. So you can see my colleague there navigating around and pushing buttons. But think about walking up to this on your first use. If you're not going to touch on the glass, where do your hands go and what do you do with them? Even with on-screen guidance, we still find that people can find it difficult to get their heads around this concept on first use. You know, so we'll see people pushing their hands forward like this, or perhaps tapping down like on a mouse. So over a lot of iterations and a lot of years of work, we've ended up zeroing in on this kind of tap gesture that you're seeing here. We've needed to make something that's intuitive for a lot of people, that will work for everybody. And for example, key to that is that it doesn't really matter which fingers you extend. We find people extending an index or a thumb, or the whole hand. The trick here is to try and determine the user's intent to select. And for us, that's been about really fine-tuning little differences in acceleration and the direction your fingers are pointing and things like that. So I'll get to more about learning and onboarding in a moment. But that flexibility in gesture is quite key. And that same logic can then be extended to scrolling and swiping, which is the next obvious interaction. So here I've got them the other way around. I've got VR on the left and I've got a touchless display on the right. So we've got a 3D UI panel in VR with a big carousel on it. And over on the touchless display, we're swiping and we've got a little turntable component. And again, in VR, it's straightforward from a user's point of view. Although there's a lot going on behind the scenes, we put our virtual hand to the panel, we detect contact, we detect the direction of movement, no problem. And then we can get the carousel scrolling. On a touchless display, this one's particularly tricky because if you think about when you might swipe on a piece of glass, we know when your finger has contacted that glass and in which direction it's turning. If you gesture in the air, well, the back and forth movements of your hand look pretty much the same in both directions. So it can be really hard to know when a user wants to swipe left or right, or when they're simply just moving their hand to move the cursor. And this is something we're still working on, but you can see sort of where we're at in the GIF. It's really come down to little nuances like changes in direction and curl of the fingers and things like that to start signifying intent for users. So across the population, gestures have got this natural variance, if you will. We all have different bodies with different heights. We've got different arm lengths, different mannerisms of movement, different things that we're able to do. We don't always have the same capabilities. Not everything is comfortable for everybody. And over our research and our testing, we've observed, I wrote hundreds when I first did this. I would even say it's probably thousands now of users going about using these interfaces, and we always see that variance, even when we give people the same interface and the same tutorials. So on screen here are a selection of some of the hand shapes we see people use when we ask them to perform a tap on a touchless display. And when you think about it, this makes quite a lot of sense, because unlike controllers or mice or keyboards, our hands are all analog and a little bit different shapes, different sizes. So a gestural interface actually has to be a bit generous. It has to work with the variance in the population, because we can't expect everybody to do exactly the same thing. So one of the key principles we've learned is that gestures are not these precise, fixed actions that everybody has to master. They instead encompass a small range of hand shapes and a range of movements that we classify as all signifying the same intent. Now, so far, everything I've shown you in VR has been a form of direct selection. So by that, I mean the virtual hand making contact with the button directly, which makes a lot of sense when you're using your hands in VR, but there is another way to do it as well. So this grab, select interaction is the way that we can push buttons or select objects from a distance in VR. The difference is it needs a ray or a cursor, something protruding from the hand to tell you what you're pointing at. So you can see that there. And it also needs a new gesture, some way to toggle or select that object from a distance. And as you can see here, that's using what we call a pinch or a grab gesture. It's closing some or all of the fingers together. And if anyone here has used VR with hand tracking, then you've probably done this or some variation of this. It's becoming a very common gesture already. The thing I want to point out is that what we're doing here is really similar to what you saw my colleague doing on the touchless display a minute ago. We're effectively selecting something from a short distance. But whereas here, the grab makes most sense to users, on the touchless display, it was the tap gesture. And I can say that confidently because we tried both in both places. So the lesson here is that gestures are also not universal. The choice of gesture will depend on the scenario and the device. So now I've shown you a grab, I can introduce you to virtual objects, which are, if you haven't worked in 3D before, they're almost a new class of UI component that you can start having once you get into spatial interfaces. We usually use these in VR, but we have started using them on touchless displays as well. So virtual objects are, like the name says, they're a lot like their real world counterparts. They have gravity and physics. You can grab them, throw them, drop them, push them around, knock them over, and they react as you would expect in the real world. On the airline training application I showed you earlier, virtual objects are quite a big part of the experience. In that scenario, they will be food trays and cushions and fire extinguishers and things like that. And just like the tap and the scroll gestures we've looked at, you need to build in this flexibility in the way that people can interact with these objects. So in some of our early versions, we would always ask people to form a pinch with 2 fingers to pick up those objects. And as we've tested and refined this, we've seen the variation in the way people go to pick these things up. So we've ended up building in more of a physics system where people can grab with any fingers and in any orientation that makes sense to them. As long as the object reacts with the appropriate physics, then it always feels realistic. Now, the way that people will interact with those objects is also dependent on the design of the object itself. Things like its size and its shape and its appearance. So if you look to the images on the right, this is how people tend to pick up different objects when they're different sizes. So the smallest ones, we will instinctively go in with a thumb and forefinger with a kind of pinch. Larger objects get a whole hand. And when people see big objects in VR, they almost always go in with 2 hands. It's this instinctive thing that everybody does. The other thing to bear in mind is that objects need to be able to signify somehow whether they are interactive or not. So they need some kind of signifier that can say, yes, you can interact with me, especially in these sort of realistic, busy environments we see in training. So in the example on the left here, I've got one of the ways we do that, which is by having a little annotation label pop up when the hand gets within close proximity. But we've also done things like have them light up or snap towards the hand and stuff like that. The 3D objects can also communicate a lot about how you use them through their form and their appearance. And I'm sure the designers on the call are nodding. I'm talking about affordances, which is, for those that don't know, the way a UI component or an object can tell you about its intended use through its first appearance. So you look at it and go, oh, I get it. It's got a handle on it. I'm supposed to pick it up or something like that. I usually give the example of a bowling ball when talking about this. It's got 3 holes in it. You just know that your 3 fingers go in those holes, and that's how you pick up a bowling ball. And with virtual objects, we find ourselves doing a lot of the same stuff. As an ex-industrial designer myself, that's quite interesting that digital interfaces have gotten 3D and gotten to a point where a lot of the principles I learned as an industrial designer actually apply to these virtual objects. You can make them easier to read and easier to use by considering their form and the things that are noticed first. So as I'm getting to, a lot of these interfaces are better for hands when they are 3D. As opposed to, say, a flat UI panel, it's better when these interfaces have some physicality, some depth and some texture and some movement. So if you think back to when I showed you that GIF of pushing a button in VR, it was important that the button depressed when the finger made contact with it. So at Ultraleap, we always give our buttons that physicality. We have them raised off the surfaces of UI panels and keyboards. We need to see them moving when they're pressed. You can also see here, and say on the keyboard on the right, there are these tiny ball-shaped objects we have around them. So these are little miniature virtual objects. And as you can see, we can grab them to reposition components or angle them, or even grab two and resize them. And we find they work really well because, you know, grabbing something that's two-dimensional when your hands and the environment are 3D is just a bit weird. It's always a bit more instinctive to make it a little object like this. So the more we refine these interfaces, the more work we do, we always find that that three-dimensionality and that physicality helps people. So another interesting thing about VR is that people are moving around this virtual world. For anyone that hasn't used VR, you know, you put on the headset and, you know, I'm in a small office right now and I can get up and walk around my small office. But if my virtual world is bigger, then I'm just going to walk into the wall. So most VR applications have some means for you to be able to travel or locomote around a bigger environment without having to physically move. There's often a way of teleporting across a space or snapping yourself around. But for designers of VR applications, that means you've got users who are on the move, but they obviously still need access to menus and to panels and things that they had when they were standing still. When you design for VR controllers, it's normal to have a dedicated button that would say, bring up your main menu. But what's the equivalent for hands? As you're probably getting from the title, wearable UI is the Ultraleap solution to that. So it's a way to access features anytime, carry them with you as you move around the space. Effectively, we're mounting UI components onto the body. So as you can see here on the left, we've got a little UI panel coming off the hand. And it works very well when they're on hands and wrists and forearms. But if they were always present, then they would interfere. They would get in the way when you're doing other stuff. That would get pretty irritating pretty quickly. So we also need them to turn on and off and only be on when they're required. So in a couple of examples here on the left, you can see turning the palm up to face the hand spawns this little UI panel. This is an example of like a drawing application. So I've got a little brush slider. I've got a clear and undo button there. Frequently use controls like that. On the right, a slightly different take on it. So this is a fun application where we're dropping plants and greenery around an office environment. And the way we do it is by opening the palm of our left hand. And there we have little plants anchored to the end of each finger. And you select by pinching and effectively plucking them off your hand, dropping them into the environment. So both of these allow you sort of a way to quickly access that stuff and then move freely around the environment as you use it. Now, unlike a touchscreen, spatial interfaces can't usually give you tactile feedback. When you tap a touchscreen or even when you pick up a real-world object, you feel that resistance against your fingers. And that gives you a bit more certainty that you pushed the button, picked up the object, or whatever it is. When we design for these kind of interfaces, we have a lot more freedom in where we put things in 3D space, but we sacrifice something in terms of confidence and certainty. It's a little less clear when you've pushed your virtual button, when you don't feel anything on your fingers. So to try and give back people that confidence, we've found it really helps in our team to exaggerate the response of the UI. And by that, I mean the visuals and the audio are just a bit more dialed up than what you might do with a typical web or desktop interface. So in the keyboard again on the left, my VR keyboard here, you can see as my finger gets close to the keys, they're changing color. That's a proximity thing. So they're lighting up to indicate, yeah, this is my signifier, you can push me. When we start pushing, we get feedback too. So on the touchless display on the right, you can see, if you watch the cursor, there's a little fill animation going up and down in response to the hand's backward and forward movement. In both these scenarios, buttons depress with this sort of exaggerated, obvious motion. And when the button gets to the point of activation, we play a nice loud audible click sound. We show another color change again. Now this stuff is more exaggerated than we might be used to with some of our interfaces, but this is a usability thing. We know that particularly when learning. Giving people that extra confidence that they've completed the action makes a big difference to people getting to grips with these things quickly. So speaking of feedback, there are other ways to give people that confidence back. I mentioned at the start, we work with haptics too. So at this point, I'd like to introduce our other technology, which is our mid-air haptics device. I won't get into exactly how it works right now, but basically it will also track your hands in 3D space, and it can send haptic sensations to any part of your hands, to the palm or the fingers. It can animate them around your hand and things like that. So we've got another tool in our toolkit as spatial interface designers, but what can we do with haptics? So this is a prototype of a driver interface, an in-car HMI interface in development at Ultraleap. So you've got our driver in our simulator there. You've got the main screen, which would be what's on your dashboard. And you might be able to just see all these little silver cubes at the bottom of the prototype. That's the haptics array. That's what's sending the haptics up to the hand. Now, as our user navigates around the buttons of the interface like they did on the touchless display, we can send a low intensity haptic to their finger. It's just a tiny little buzz to give them confidence they're moving in and out of target areas. In this prototype, they can tap a button either by tapping on the screen or gesturing in the air. But if they make a tap in the air, we can send a more intense haptic sensation to the finger to give them feedback the button's pushed. You'll also see our driver here pinching their fingers and using these slider components up and down, left and right. And that might be to change the volume of the music or the temperature in the car. And again, we deliver a low haptic sensation at the low end, and as they go up the scale there on that slider, we'll raise the sensation, lower it as they go down. So this gives you an example of how you can add this haptics technology into these interfaces, and it kind of bolsters the experience. It gives you this extra certainty, this extra confidence as you're getting to grips with it. Now I'm going to contradict myself. So I said earlier that gestures are never precise fixed actions. They're always flexible and they've always got a range. But actually you can do something with hand poses. So by hand pose, I just mean that I've formed a shape with my hand. It doesn't really matter where I move it, just that I hold the shape. The system has recognized that shape and it's triggered some action. And usually we use these for shortcuts or for bringing up menus, or for fun features like in the art application on the left, we can pinch to draw in 3D space. So examples of hand poses would be an OK or a pinch, a thumbs up or a thumbs down, or holding up different numbers of fingers. So they're really powerful, but the tricky thing with them is that you have to hold them in working memory whilst you're busy doing other stuff. And in VR, you might often be very immersed and very busy. So really they become a bit like keyboard shortcuts. It becomes a difficult thing to remember them and recall them when they're needed. In most of our applications, we advise our customers to use them quite sparingly, but they come into their own with repeat uses. So if you've got an application that people are using frequently, maybe every day or every week, then they have the capacity to gradually learn these and adopt them as kind of power user shortcuts and things like that. So one of the big challenges with these interfaces right now is the learning aspect of it. It's about helping people to understand what these interfaces are and how to use them. They can be incredibly immersive and natural and fun, but for most of users of these interfaces, it's going to be their first time. Now, if you go into VR and you put on a headset, it's very easy to understand you're in a 3D space. I mean, you just put on the headset, so you're expecting it. But you have these virtual hands, which you feel very embodied with. So it's very easy to understand things like grabbing objects, etc. But even there are these VR-specific concepts that need to be taught. So things like the wearable UI, where I turn my palm to bring up the menu, you don't have that in real life. This is something that you need to be shown through in-world prompts or tutorials. With touchless displays, we've got an even bigger challenge in some senses, because you could walk up to one of these screens in a public place and not know that it's touchless. It doesn't look different from an industrial design point of view. It's only when you start using it that the difference is apparent. So we have to do a lot to grab people's attention. and teach them very quickly that this is touchless and how it works. We really only have a few seconds to do it. Now, on the bottom left, you'll see an example of some text prompts being used in VR. And of course, we started out with a lot of this, but we quickly learned that they only go so far because there's not really prior knowledge about what to do with things here, with gestures, etc. Text prompts are great for drawing people's attention to things or for reminding them of something they knew. But there's a real limit to what text and icons can do in this scenario. There's just not that familiarity with how you move and what you do. So saying make a pinch is not clear enough. It tends to elicit a whole range of responses. So the golden rule is to show, not tell. Definitely with spatial, definitely with gesture. And you can see here some of the other tutorial formats that we've been working with over the years and been gradually refining. Things like little characters that show you what to do, little videos and animations of hands in 3D space, or even in the bottom right, examples of in-world prompts or guidelines that show you how to form a pose and where to put your hands. So all of these are following those principles. When we show people what we mean, it's much clearer and we see much more effective learning. So by now you've seen that these spatial interfaces can potentially be very different to the stuff we usually do on screen. It can be all around us. The interactions, especially with gesture, can be a lot more physical than people might be used to on their phone or their laptop. And so the human factors or ergonomics side of this becomes even more important than it is on screens. If you're a designer and you're choosing gestures and placing components in 3D space, you've really got to think about frequency of use, about the effort required to grab something or push it, the comfort. You've got to think about the depth and how far away stuff is from people. So again, with that wearable UI, that little menu where I turn my palm over, that's brilliant for occasional use. But if my color palette was in there and I was going to be turning my wrist all the time, that would very quickly get uncomfortable. On a touchless display, I can reach up high to tap a button on a big screen, that's fine. But if you wanted me to hold my hand up and use a slider or a dial, it's going to be above the shoulder and I'm going to get tired quickly. So there are no standards really yet for this stuff. There are a lot of parties working on it and we're trying to contribute. You can't easily see usability or accessibility guidelines on things, but our research is already showing just how important it's going to be. So that's going to be a real focus for us over the next few months. And one of the things we want to do is ensure that a lot of the interactions I've shown you can be more inclusive. So we know that, for example, with some of the hand poses and the two-handed interactions, we need to offer alternatives for certain users. Another thing that we're going to be working on over the next few months is looking more into mixed reality. And that's because our tech is getting embedded into a new mixed reality headset that's coming out soon called the Lynx. Our team has started looking at how some of these virtual reality principles might need to adapt when we get into mixed reality. So I want to show you a sneak preview of some of the stuff we're working on. Here's a prototype. You're looking in the Ultraleap office. We've got a real cardboard box. It's got an egg going in it. You'll see why in a second. Our user hits a virtual button on top of the box, and our friend Mr. Owl pops out the box. They're now going to use a hand pose to call the owl over to sit on their finger. And then with their right hand, they're going to control a spatial cursor. They're going to navigate his flight path around the room. And here they're controlling the depth of the cursor with these really subtle back and forth movements of the hand. So this is the result of a hackathon and a design sprint from a few weeks ago. It's early days for us on this, but it gives you an idea of some of the stuff we're looking at as we try to figure out best practice for interactions in this world. So I'm coming up towards the end. We're going to be open for questions in a minute, but I couldn't finish up without mentioning that we've got published design guidelines, which are freely available to everyone here, where everything I've shown you today and more detail than I could get into here is all covered and written up. So that's at docs.ultraleap.com, and I'll leave the link up at the end. That's freely available to everybody. So if you found it interesting and you want to know a bit more, that's a brilliant place to go and start. You're also really welcome to get in touch with me, and I'll put my details up at the end as well. And of course, we'll get to questions in a minute. So maybe I can answer some of your burning questions now. So with that, I'd like to say thank you very much for listening.
Hi, Matt. That was great. That was wonderful. Really enjoyed it. I learned a lot. And it's new to me. I mean, I don't think I've yet interacted with a touchless display. And you mentioned, I was interested by the fact that there are these sort of different shaped hands, different nuances and movement. How forgiving, but also that you have to do a little bit of teaching. You have to sort of teach people the right way to interact. But how forgiving is the technology in terms of, you know, one person doing it slightly different to another? Is that a real problem?
It's not a real problem. It's just something that we're having to refine a lot over time. You know, the technology always knows what your hands are doing. Effectively, what we're programming in is what different gestures mean. So if I want that to mean push the button and that, then I have to tell it what all that is.
Sure.
So you know, for us, it's not about the limits of the technology so much as what do we expect people to do.
Absolutely.
And most of the learning has come from the last couple of years. If we started going out and doing pilots in public places and things like that, like you always get with user testing, but, oh, whoa, I didn't expect anyone to do that. You know, we're seeing things that we never guessed. We're like, right, but better get back to the lab and, you know, fine tune the settings a bit more to allow this new gesture. There is a balancing act, because if you made, you know, if you've got an application with just one thing, if you're just pushing buttons, you can open it way up and say anything vaguely moving forward would count. If you've got a lot of interactions, a lot of stuff going on, then you need them all to be distinct.
Right.
And so there you know, of all the things the hand can do, you need to decide where the lines are between what counts as a pinch and what counts as a tap. So there is a degree of balancing, really. I think in most cases we find you don't want to have too many different gestures in one place anyway. But yeah, still learning as we get more and more exposure to different people and different scenarios, I guess.
Yeah. Alexis has asked a good question, which is, what are some of the benefits you see for a touchless display over a true touchscreen? Was it all driven by sort of hygiene originally, but is it the fact that it actually allows a much richer set of interactions?
That's pretty much where we've got to. When we started that project in 2020, it's the same technology that we use in VR. And when COVID started in the UK, we were getting approached by companies saying, can you make a touchless touchscreen? We think people might be nervous in the future of touching screens in public places. And I don't think, at least not in the UK, that's not really panned out as much as we thought it might. What's been really interesting is, as we start building it, it was the richness of the experiences that we didn't expect. It's just being able to know more about where somebody is in 3D space and what their hand's doing means we're finding being able to do all these 3D interactions and things like that. It's sort of adding a layer of richness to touchscreens that we didn't have before. So yeah, we started in one direction, and I would say it's gone much more in the direction of retail and galleries and museums, where they want to make us quite a rich, entertaining experience and things like that.
Makes sense. There's another good question about the haptic feedback, and this is something I was desperate to ask. Well, how is that sensation of haptic feedback mid-air actually produced? Is it physically the air is moving, or is it something electronic sensation? Is it unpleasant? Do people mind this?
Yeah, it's a weird thing to explain when you've not tried it. Everyone who starts at Ultraleap, that's the first thing we go and try it, get familiar with it. It's a form of very low power ultrasound. So it's ultrasonic transducers, almost like tiny little speakers. And in that black box is this grid of these tiny little speakers, effectively. There's then the same cameras built in. So the camera's following your hands, and then it's telling this array of speakers where to send this super low power ultrasonic pulse to your hand, and it's precise enough it can send it to different parts of the palm or the fingers and things like that. It feels like a little buzz. It feels, if you've ever used screens with haptic feedback, it's not a million miles away from that. Because we can do a lot to kind of change the size of pulses or animate them, we're able to go a bit further than those kind of devices were. And we're still sort of seeing how this pans out in different use cases. But it's not unpleasant. It's just
okay. Good. I'm glad to hear that. I want to squeeze in one more question. A good question about accessibility and alterability. How do you work with that? How do you cater for people who perhaps aren't able physically to do the kind of gestures that may be required by an interface?
And it's a really good question. It's something that me and the whole team are very passionate about, and it's something that we've made part of the working process here. I'm not going to claim that we've cracked everything and that this works for everybody yet, but the goal is that we'll be able to do it. So we do test with people with different abilities. We do make that part of the process. We start to find in some cases, so we've done some work with a charity for people with visual impairment and blindness, where we've tried to learn how people say use touchscreens in public right now and see if we can offer something else. So one thing that's interesting about it, if you're in a wheelchair and you go to use a touchscreen in a public place, they are rarely do they seem to be designed very well for somebody who isn't standing up, etc. When you use them touchlessly, we can track the hands in a much larger volume. So you can be seated in front of a touchscreen and raise your hand, and you get the same experience that somebody who can tap the glass would be doing, rather than forcing you to just use the bottom half of the screen or go into some strange accessibility mode. So we're still working on it, but we see potential where the technology could actually make things better in some cases. All part of the research to try and figure this out. And certainly from my point of view, it has to work. It should not exclude anyone. It should be as good as the tech there. And hopefully there are more situations where it can work for more.
Matt, thank you so much. That was a great presentation, really interesting answers as well. Enjoy your evening, your train journey to Bristol, and I hope tomorrow's test day goes well for you.
Thank you very much. Thanks for coming, everyone. Nice talking.
Thanks, everyone. Thanks for your questions. Bye.
Thanks. Bye.